Welcome everyone. Today you will discover how to make your device digital identity trustworthy and secure with STSAFE A120, a secure element designed to provide authentication, secure data management, and cryptographic services. My name is Yvonne and I will be your moderator for today. Let's quickly go over a few housekeeping details. If you have any questions during the webinar, please feel free to submit them using the Q&A widget at the bottom of your screen. We will address them during our Q&A session at the end of the presentation. You can find useful information and links in the resource widget, also at the bottom of your screen. And this one also contains the PDF of today's presentation. To enhance your viewing experience, you can expand or move the slide deck and media player by clicking in the top right corner. We also recommend closing any unnecessary programs or browser tabs that might slow down your connection. And please make sure your computer or headset are turned on. With all this in mind, let's get started.
Hi, and welcome to the STSAFE A120 webinar on digital identity. I'm Bharat, Security at STMicroelectronics, and I will explain you how you can easily integrate a digital identity into your application.
Let me start with a definition. A digital identity is used to identify an object in the digital world. In the digital world, a digital identity combines a certificate and its associated private key. To establish trust, the object must present a valid digital identity and prove that it is legitimate to use this identity. The certificate is used to verify the object identity, while the private key proves that the object is legitimately authorized to use that identity. We will use a digital signature generated by the private key that can be verified by the associated certificates. Remember, the digital signature is robust because it relies on cryptographic mechanism. A digital signature is created using a private key that can be verified by a peer. I will show an example on the next slide. The most common algorithms for digital signature are asymmetric ones, like ECDSA or RSA. Asymmetric cryptographic algorithm makes the verification step simpler. You only need the public key to verify the signature. A digital signature is used to generate a signature on any type or size of digital data. This could be a document, a certificate, or binary data. That's why signatures are usually combined with a hashing algorithm. Now, take a look at this slide. We will dive into digital signature using asymmetric cryptography. I will break it down for you step by step. First, the key principle behind asymmetric cryptography is the use of a key pair. A key pair contains a public key and its associated private key. The public key, as the name suggests, is public data. You can share it. The private key, on the other hand, is the core of the algorithm and must remain a secret. What makes asymmetric cryptography so special? The operation performed by the private key can be verified with the matching public key. Let's take an example. See Alice on the left. If Alice wants to send a signature to Bob, she uses her private key to generate it. Bob then uses Alice's public key to verify it. It's that easy. This mechanism can be used to verify a signature, but the amount of data you can sign is limited to the size of the private key. So when you have a large amount of data to sign, you will need a hash function. A hash function is a cryptographic tool that takes any amount of data and generates a fixed sized value. This is a one-way function, which means that from the digest value, calculated with the hash function, you can't go back to the initial data. That being said, a good hash function must be resistant to what we call collision. A collision is two sets of data to give the same digest value. Hence, the robustness of a hash function is the complexity to find a set of data that generate a given digest. The full digital signature scheme is using a hash function and an asymmetric cryptographic algorithm to generate a digital signature. We have seen how the digital signature ensures the authenticity of data thanks to the key pair. Remember Alice and Bob? On one side, you have the emitter of the signature that uses the private key, and on the other side, the verifier that uses the public key to verify the signature. So when you have a public key, you can verify a signature. Now what about trust? It's easy to get access to a public key, as this is a public data. To trust a public key, let me introduce the concept of certificate. The certificate is a set of data that include a public key with metadata like a validity period, a signature scheme, an issuer name, and of course, a digital signature. The certificate is signed by an issuer. But what is an issuer? The issuer is a trusted third party called Certificate Authority, or simply CA. The CA manages the certificate generation. Again, the CA is acting as a trusted third party. That's why the certificate signed by this CA can be trusted. To verify a certificate, the CA proposes a root certificate, which is generally self-signed. The root certificate is the root of trust of the certificate. As you can see on this slide, certificate can be changed thanks to the issuer name. The certificate chain can contain intermediate CA certificates or related to the root CA, for example. In that case, with the root CA certificate, we can authenticate any certificate signed on the chain. The benefit of an intermediate CA is to delegate the possibility to issue a certificate to a specific manufacturing site or to different types of products. By revoking an intermediate CA certificate, you can invalidate all attached certificates. If one intermediate CA is compromised, this will reduce the impact. Certificates are everywhere, including in our everyday life. Each time an object or a machine needs to be authenticated, there is a need for a digital identity. Let's take an example. Imagine you want to connect to your bank website. When you do that, you use an HTTPS connection. The S stands for secure. In fact, you open, well, not you, but your web browser, a secure session based on TLS protocol. TLS stands for Transport Layer Security. The TLS protocol is mandating the authentication of the remote server by the client. To do that, the remote server uses a digital identity. Once the authentication is done, a session secret is derived and the communication is encrypted between the client and the server. See on the right side of the slide the certificate from HSBC. Take a look at the contents. There is the issuer name, issued by, the validity period, and the fingerprint of the certificate and the one of the public key. Just under, you can find the certificate chain. We can see that this certificate is signed by an intermediate CA certificate from DigiCert, which is signed by DigiCert root CA. Basically, your PC has a trust store with all the root CA that are accepted. And web browsers come as well with their own trust store and the root CA certificates. Working with a certificate and a certificate authority is called PKI, Public Key Infrastructure. We have seen that the digital identity is used to secure communication. This is not the only application that needs strong authentication with a digital identity. The principle to verify a certificate to verify an object can also be applied to peripheral and consumable, again for authentication needs. The peripheral and consumable will share its certificate and then the authenticator will challenge it to check that the peripheral or consumable has the associated private key. The challenge is generally a random value generated by the authenticator and signed by the object. We will see this in detail during the live demo. Now you understand that digital identities are the core of the IoT system. And when it comes to peripheral and consumable, a mandatory tool to fight against counterfeiting. Let's see how you can inject a digital identity into your device or object. To enable a digital identity into an object, you need to inject a certificate and the associated private key into that object. There is many ways to inject digital identity. Generally, it's done during manufacturing. Depending on the manufacturing structure, There are several options with pros and cons. Take this option. You can pre-generate the digital identity with your PKI and send it to the manufacturing site. Because the manufacturer site will have access to the private keys and certificates, you need a high level of trust. Here is another option. You can connect your PKI to the manufacturer site. If you choose that option, you need to have 100% guarantee of uptime of the PKI to avoid line stop. And there is many other options. At ST, we try to make this process easy for you. Our Secure Element offers a turnkey solution to manage your digital identities. Secure Element are small microcontrollers dedicated to cryptography. They handle private keys and certificates. Secure Element generally implement both hardware and software protection that resist against physical attacks, side channel attacks, and logical attacks. Thanks to this protection and countermeasure, any attempt to extract a digital identity from a secure element implies a destructive operation of the device and requires costly investment. That's why, at ST, we create the STSAFE family. Our STSAFE product can be used as a companion chip for MCUs in a connected device or as a standalone in peripheral or consumable. In both cases, STSAFE ensures the genuineness of the digital identity by storing the certificate and make it available to the authenticator, allowing this authenticator to challenge the identity by generating a digital signature. How does STSAFE make your life easy? Well, adding STSAFE to your device removes the need to inject a digital identity during your device manufacturing. And there's more. STSAFE comes with a digital identity, and this digital identity can be personalized for your application. Stay with me and you will discover how. Why should you trust ST Secure Element? First, STSAFE products are designed and manufactured by our Secure Microcontroller division. This division has more than 30 years of experience in certified secure MCUs for banking cards, smart cards, and embedded SIMs. Second, we have shipped more than 15 billion secure chips so far, no less. And there's more. STSAFE comes with an in-house secure personalization services. These services help to manage the digital identity. STSAFE includes two main product lines. The STSAFE A, an optimized secure element that helps manage any digital identity for IoT security as well as for brand protection. And STSAFE TPM, which implements the standardized TPM 2.0 specification. In this webinar, let's focus on STSAFE A. The STSAFE A family offers an optimized solution based on a certified secure element for strong authentication by managing the digital identity of a device. STSAFE A can be easily integrated thanks to the I2C bus with the host MCU or MPU. STSAFE A comes with preloaded initial digital identity signed by an ST certificate authority. Here is a demo setup. I will give you more details soon. Let's see this demo in action.
Ready to see how ST companion chip authenticates devices? Stay with me. First, let me introduce you the STSAFE A120, a turnkey solution that authenticates devices even offline. You can easily integrate this companion chip into your peripheral, consumables, and batteries. Now let's see this chip in action. For this demo, we will use a device made of ST evaluation board. A Nucleo L476RG will be used as a main board, and the XNucleo ESE01, which is the STSAFE A120 evaluation board. We will connect this device to a PC with a USB cable and use the serial COM port to communicate with the PC application. As you know, authentication helps protect business revenue from stopping fake or copied product. So let's start with this use case, the strong authentication. Here is a demo application that runs on the PC. This is a Python application that will connect to the device, our Nucleo L476RG board with the STSAFE A120 through the serial COM port. In this use case, the application will act as an external authenticator of the device. For instance, when you plug a peripheral to a main unit, the main unit is the authenticator. Once connected, you have on the left side of the scenario and the resources of the devices. Here we can see the 5 private key slots available with STSAFE A120 and the 11 memory partitions. We have the size of the memory partitions, and some of them have a star which indicates there is a X509 certificate inside. In the middle, we have the description of the use case we will achieve, and on the right side we have 2 log areas. The top one, Authenticator, is for the log of the PC application that will authenticate our devices. The bottom one is the traces from the devices. By selecting our use case, we can see that 1 slot and 1 memory region are now in green. We will use these resources from the STSAFE A120 for our tests. Strong authentication requires a certificate that can be verified by a certificate authority, and the device needs to have access to the associated private key to sign the challenge sent by the authenticator. Let's run our scenario. First step, we are asking the device certificate. In the authenticator log, we can see it. We have the PEM representation, which is the standard way to exchange a certificate in a text mode. And we have the past certificate version. We can see the common name of the certificate and the issuer name. In our case, this is the STM STSAFE A Prod CA01, which is our default CA that signs the STSAFE A120 evaluation sample certificates. Now we can check the authenticity of our certificate. The PC application has the STM STSAFE A Prod CA01 certificate, and thanks to this certificate, we can verify the STSAFE A120 certificate we have just received. Great! This first step is now done. We have an authentic certificate from our devices. Now let's move to the second part of the authentication, the challenge. The PC application that acts as an authenticator will generate a 32-byte value randomly, which is the challenge. This challenge is sent to the device that must be authenticated. The device signs the challenge with its private key and sends it back to the authenticator. In our case, we will use the private key slot 0. Here is the generated signature. If you are familiar with ECDSA signature format, you can recognize the structure of the binary data. If not, you are seeing an ECDSA signature for the first time. We have our signature, and from the device certificate, we have the device public key. The authenticator can now check the signature and verify if our device is a genuine device or not. For this example, this is a good one. Now, what's happened if we modify the certificate or the private key? I will change the setup of my use case by changing the private key slot 0 to the private key slot 2. If I rerun the scenario, you can see that there is no change in the certificate authentication. We are receiving a signature, but now when we try to verify the signature, we can detect this is not a correct signature, which means the device is not a genuine one. What happened in this scenario? A fake device can access a genuine device certificate as the certificate is public by nature, but it can't access to the associated private key as the key is safely stored inside the STSAFE A120 embedded in the device. So we can't make clones that can be recognized as a genuine device thanks to the STSAFE A120. What happens if we didn't receive a genuine certificate? I'm selecting memory region 2, which has another certificate. I rerun the use case. If we look at the certificate, this time the command name and the issuer name are different. Therefore, when performing the check of the certificate, it fails and it's not recognized. With this example, we highlight the interest in having a dedicated certificate authority for your application. With this demo, we have seen how strong authentication is done in a standalone. This is used when you are authenticating a peripheral or consumable. The resources of STSAFE A120 are used as the root of the security, and we are relying on the digital identity provided by STSAFE 120. Now, let's look to another example. For this use case, our device will act as an IoT device, and it will connect with an IP socket to a remote server. The remote server will be played by the PC application. So, on the right side of the screen, we have 3 different views. The top one is the device log. In the middle, we have a network spy. This will be the view of anyone who might sniff the Ethernet traffic. On the bottom, you have the server logs. To illustrate our demo, let's start with an unsecure connection. In that case, no resources from the STSAFE A120 are needed, as no specific security asset are required. The device is opening a basic IP socket to send HTTP command like GET to the server. On the device side, we see that we have opened the socket and send a GET request. As this is an HTTP request, this is a clear text that is transmitted. And we can see on the network SPI that the data transmitted on the network is a clear text as well. On the server side, we can see the server output acknowledging the connection. So let's move to the HTTPS use case, which means that we will add the security layer on top of our HTTP connection. Now we will use a secure connection using TLS protocol, which is the most commonly used protocol for secure communication over Internet. In our case, we will use mutually authenticated TLS session. This is a typical use case in an IoT context. As an IoT device fleet is known by the manufacturer, then we can strengthen the cloud connectivity solution by requesting a mutually authenticated TLS session. Therefore, on the device side, you will need to have a certificate and an associated private key. Good for us, we do have the STSAFE A120 embedded in our device, which is pre-personalized with a digital identity, a certificate and an associated private key. I'm now selecting the secure session use case, and you can see the scenario is a bit more complex, but this is a standard TLS 1.2 unchecked protocol. On the device side, we configure the memory region for the certificate and the private key slots. Here we will go for a pre-personalized certificate and keys. And we run the use case. In device traces, we can see the setup of the HTTP client with the explanation on all the steps to configure the TLS stack. Here we use embed TLS as a TLS stack. In yellow, you can see the operation executed by the STSAFE A120. So we have the certificate reading, we have the random generation, and the signature generation, of course. Once the TLS uncheck is completed, the device sends the HTTP GET request to the server. On the device traces, we can see the HTTP GET request, and the server answer is now more customized as the remote server has authenticated the device thanks to its certificate. If we look at the network traces, we no longer recognize the data exchange by the device and the server, as they are encrypted. But if we scroll up, you can see some clear text in the beginning. This is the TLS unchecked, and during this uncheck, we have the certificate exchange from both sides. And you can see that this is the certificate because it's in clear text, and this is mandatory for both devices to authenticate each other. In this demo, we have configured the embed TLS stack to use the STSAFE A120 resources in order to achieve a mutually authenticated TLS session. We can have a look at what happened when the certificate or the private key does not match. What if I change the certificate from my device and run the scenario again? We can see that the uncheck is failing. The remote server is not able to authenticate the device certificate, and then it closes the connection. On the device side, we have an error during the TLS uncheck. On the network side, we can see that the first TLS unchecked exchange and then a closure from the remote server. On the server side, as the connection has not been accepted, there is no log. What if I change the private key from the device and rerun the scenario? The TLS uncheck is going further, but when the server challenge is checked by the server, the connection is rejecting, and once again, the server denies the connection, and there is no log on the server side. With this demo, we have seen how strong authentication is used in TLS session for secure remote connections. The resources of the STSAFE A120 are used as the root of security, and we are relying on the digital identity provided by the STSAFE A120. Now, it's time to explore the STSAFE A120 in details.
STSAFE A120 is the latest secure element from the STSAFE A family. The STSAFE A120 is based on the recent certified Common Criteria AL5 Plus hardware and comes with personalization services. In other words, it's an optimized solution for digital identity management. Thanks to the I2C interface on the hardware side and the STCD on the software side, you can easily integrate STSAFE A120 in your application. STSAFE A120 has an updatability mechanism to address potential future security concerns. For those who are familiar with cryptographic algorithms, let me add that STSAFE A120 comes with enhanced cryptographic feature. It supports ECC curve up to 521 bits for both NIST and Brainpool curve, as well as the Edward curve 25519 for the asymmetric part. And on the symmetric part, it supports AES 128 and 256 with several flavors, as well as HMAC and HKDF functionalities. Regarding resources, STSAFE A120 offers 5 asymmetric permanent key slots and up to 16 symmetric permanent key slots. It also comes with 16 kilobytes of industrial-grade NVM. The secure channel between STSAFE A120 and the host MCU has been updated to be more robust with increased longevity compared to the previous generation. Secure symmetric key on-field provisioning is also available. I have mentioned the Common Criteria EAL5 Plus certification. If we look at the classification of the security level, we can see that ST certified secure MCU are providing state-of-the-art security. The Common Criteria certification is a standard that is used in banking applications to evaluate the level of resistance of a secure element. Common Criteria evaluation is made by certification laboratories and evaluate both software and hardware implementation, but also covers the full life cycle of the product, from design to manufacturing. This is ensuring high level of protection for the cryptographic asset stored and used by the secure element. The plus in the evaluation indicates the product's resistance to physical attack. The sublevels are AVAVAN 1 to 5. STSAFE A120 offers state-of-the-art security with the Common Criteria EAL5 Plus AVAVAN 5 certificate. STSAFE A120 comes with a full ecosystem, from evaluation sample with the ST-SAFA 120 S8 SPL05 part number to the evaluation board XNucleo ESE01A1. The ST-SAFA 120 S0 S8 SPL05 is a versatile evaluation profile with an ST preloaded digital identity. This profile allows you to test and fine-tune your configuration for all use cases offered by the STSAFE A120. The XNucleo board provides an Arduino connector to ease prototyping and evaluation, and it's fitted with the ST-SAFA 120 S8 SPL05 samples. On the software side, the ST-ECLib is available on GitHub. This software library offers a high-level interface to interact with STSAFE A120. No need to manually craft the I2C command to the STSAFE A120. The ST-ECLib is managing it for you. Same for the secure channel. You only need to give access to the cryptographic primitive, and the ST-ECLib will take care of the commands protection. If you are using the STM32Cube ecosystem, the Xcube ST-AC01 provides code generation and configuration to simplify integration on your board and software. Like other members of the STSAFE A family, STSAFE A120 comes with personalization services, also called pre-provisioning services. At ST, we provide these personalization services out our ST Secure Factory. This ST Secure Factory is part of the Common Criteria evaluation. It's in this Secure Factory that Certificate Authority Private Key is managed within an HSM. HSM is hardware security module, which is isolated from external network and has restricted access to ensure highest level of security of the private keys used for the certificate signature. Thanks to this HSM, ST ensures the highest level of security when pre-provisioning your digital identity into our STSAFE A120. The personalization of the STSAFE A120 is made of the digital identity. Both the private key and the certificate are provided within STSAFE A120. You can also have a dedicated ST Certificate Authority to simplify your application or to be used as an initial digital identity, which enables the secure enrollment to your PKI. On top of this digital identity, you can also customize the memory mapping to adapt to your application. You can configure the symmetric key table if needed. Some of you may have experienced from time to time an I2C address conflict on the hardware. The good news is STSAFE A120 has a configurable I2C address. STSAFE A120 also comes with password protection and common configuration to enhance security. And as you will have your personalized digital identity into STSAFE A120, you will get your own part number. Let's see how the digital identity works with your PKI.
Now that we have covered the need for a secure element and the challenge of registering each device individually, let's explore how the ST pre-provisioning that comes with the offer of the STSAFE A120 can take you to a step further. As we have seen, ST can load your unique key and certificate at our factory before shipping the chip to you. This pre-provisioning process simplifies deployment and enhances security for your implementation. For our last demo, we will show how you can use the initial digital identity provided by the STSAFE A120 to enroll your device in a secure way to your applicative PKI. What is the benefit of this use case? Thanks to the preloaded digital identity, you no longer need to inject your applicative digital identity at manufacturing sites. You can, for instance, use the end-to-end secure connection to your PKI at installation time to inject your applicative digital identity, regardless of the connection technology used for it. If you also need to install end customer specific certificate, you have a secure way to do this installation thanks to the STSAFE A120 preloaded digital identity. Let's see it in action. In this case, we will use the STSAFE A120 embedded in the device to open a secure session to the PKI server. The PKI server will automatically identify the device thanks to the certificate provided by the STSAFE A120. Then the PKI server will provide some information on the CSR, the certificate signing request, to be generated on the device side. The device will use the STSAFE A120 to generate a key pair and to generate and sign the CSR. Then the PKI will generate the certificate based on the CSR with the applicative CA certificate. And finally, PKI will use the secured session to send the certificate back to the device, and now our device has a new digital identity installed in a secured way. Thanks for your attention.
As mentioned before, STSAFE A120 has a firmware update feature which makes it compliant with RAID and CLA requirements. STSAFE A120 is a perfect companion for your RAID and CLA compliance solution. It's a highly secure solution that handles the digital identity of your devices. Also, the STSAFE A family is part of the ST PCERT strategy to communicate on security incidents. I encourage you to watch our series of webinars where you can find more information on ST solution for RAID and CLA, including STSAFE A. To recap, digital identity management is a key element in IoT devices. Securing communication from device to cloud is the first step to ensure the security of your solution. The STSAFE product family offers a wide range of solutions designed for all types of IoT and industrial automation systems, as well as for the authentication of peripheral and consumable. STSAFE A is more than just a secure element. It's a solution based on certified Common Criteria EAL5+ hardware that combines a high level of security with personalization services. And finally, we have seen that STSAFE A120 personalization services offer a simplified way to manage the digital identity of your application. You will find all the resources, including useful links, in your interface. Thanks for your attention. I hope you enjoy the demos. Now let's start the Q&A session.
All right, and to answer your questions, we have Keith and Kyle here with us. All right,
Hello.
welcome. All right, let's have a look at these questions. Okay, let me start off with this one here. I'll push it for everybody to read. I have an MCU with security features in my application. What is the added value of an STSAFE A120 in that case?
Oh, that's me. Well, okay. So Keith Walters here. Yeah. So for the addition of having an ST safe in the application is the fact that the ST safe is a secure enclave. It has a physical anti-tamper on the die. It also has hardware accelerators on it, so it can actually generate keys. It can store keys securely and also generate keys on the fly. So this is the additional capability that an ST-Safe A120 can bring to the table by offering that physical anti-tamper capability to your application to ensure that those keys never get out in the open.
Yeah, and our chips are certified EAL 5+, so they're more tested and secured than a MCU might be, as well as we also provide pre-provisioning for keys, so we can serve as your PKI and actually provide you with the keys that can simplify your setup, so you don't need an HSM on your line in order to issue certificates. You can trust that you're getting the device pretty much prepackaged with these certificates.
Our next question is coming from Trevor, and Trevor says, we noticed that the latest Xcube STSI01 middleware includes the STSE-lib version 1.0.0, but the latest STSE-lib version on GitHub is version 1.1.2. Are there any potential issues with updating the STSE-lib with the Xcube STSE01?
Sure. So I think the question is asking if you can update the older version with the latest version, and yes. So there's inherently some latency in whenever we push updates to our GitHub. So our 1.0.0 is, because publishing online is a little less immediate as the GitHub. So if you want the latest, always pull from GitHub, and you can update your STSE-lib with the GitHub contents, and it'll be backwards compatible, and it'll also supply new features potentially, or any bug fixes that could potentially we might have found. So yes, you should. You could definitely update your 1.0.0 with 1.1.2, and you shouldn't have backwards compatibility issues.
Our next question is coming from Steve. Will this webinar be recorded to watch later? And I can answer that question. Yes, you will receive after this webinar a post-event email with the link to the on-demand version of this webinar, so you can watch it as many times as you like. Then we go to our next question from Nicholas. Is the ST-Safe-A suitable for LoRaWAN OTAA scenarios?
The ST-Safe A120 can be used in conjunction with a LoRaWAN system. So typically in most LoRa systems, you use AES 128. So the ST-Safe A120 does have that one ephemeral key slot, so you could generate a session key for computing the AES 128 key for then doing any sort of like firmware updates over the air. So it's really physical medium agnostic. The ST-Safe A120 is essentially a security coprocessor and secure enclave. So if it's LoRa, Wi-Fi, Bluetooth, wired Ethernet, the ST-Safe-A can assist in those situations and generate those keys securely.
All right, thank you. Our next question. Does ST recommend using ST-Safe A120 with STM32 cryptographic or Mbed TLS?
Right. So this question is kind of dependent on your situation. Obviously, our cryptographic libraries are streamlined for our specific processors. So, I mean, it wouldn't hurt to use it if you're using an STM32. Our example code will use the fill-in cryptographic, the STM32 cryptographic library wherever it needs to do any crypto on board. But Mbed TLS is fine. I know on our old models, or our old A110, we provided examples for both, but with latest Mbed TLS, it's harder to basically overload they haven't provided a way to overload the secure element to do certain functions. So we're waiting on a fix from Mbed TLS before we submit any of those changes or updates to our code. But in general, either one is fine. It just depends on, how much space you've got, whether you want the entire cryptographic package, or embed TLS. I know you can pick and choose, so you might be able to streamline your size a little bit by that, using specific modules versus the entire package. Like the cryptographic library requires you to build the entire library because we don't provide the source code for that. So it all depends on your use case, but hopefully that may have clarified a few points to look at in your specific use case.
All right, thank you, Kyle. We'll move on to our next question. It's an important one. In case of questions or technical support need, how can I get some help?
You can actually enter a request into our OLS ticketing system if you have a detailed technical question, then that will get routed to the correct technical person. Or if you have a connection with your local salesperson, that's another way of getting any of your technical support needs met.
All right, then we move on to our next question coming from Dan. And Dan says, communications between the secure element and the MCU are over I2C. Is this vulnerable to an eavesdropper, or even worse, a man in the middle?
Kyle, do you want to get that? Or I can do it if you want.
I'll take it right here. So in general, there are certain functions that you could use a secure element for that may not matter whether they depending on your stance, but some things like using the key for a signature and something like that, if somebody is snooping the line, then there's not really much they can get out of that signature value. It's just proving that the identity is there, as well as man-in-the-middle type attack. For a signature generation, they don't have the keys, so they can't generate the proper signature anyways. There are other use cases, such as ECDH keys generation, some other features in their secure memory and stuff like that, that we do provide host keys, which basically whenever you are setting up your ST-Safe, you can program in with A120, you can do this setting the keys directly, or you can use an ECDH ephemeral key type process to generate keys on both sides without it ever crossing the line. And once you have established these host keys, it's a CMAC key and an encryption key. Certain commands can be set up so that they require you to either prove your identity, such as with using the CMAC key, or actually having line encryption. So if you want to protect data that you're transmitting to your secure element, whether it's wrapping a key and you don't want that key to be on the line, you can encrypt it with these host keys. This just requires setup one time during your factory provisioning side. Once you get the chip, this would be connected to the MCU. And also what this does, especially if you're requiring these CMAC type keys or CMAC authentication with the ST-Safe, it basically pairs the two together. So the ST-Safe A120 will pretty much only operate with that specific MCU. So the eavesdropper case can be solved by the encryption key, and a man-in-the-middle attack could be solved by the CMAC, where you're basically requiring that person to approve their identity with the CMAC key. So yeah, that is the gist of it. Using the host keys, we're able to kind of control this, and depending on your use case, maybe you're doing something that doesn't require host keys, and we do provide this capability. And with the A120, you can actually configure commands on your end to either require CMAC or require encryption, and that can all be done on the customer side. In the past, our A110 required us to do that in factory, but now we've set it up so that our chips can actually be configured on the customer side to require these, so it doesn't. It's not as a restriction. You can decide at some point to change these if you so please.
All right, thank you, Kyle. We'll move to our next question. Is the ST-Safe A120 a TPM?
No, it is not a TPM. So the TPMs typically comply to the Trusted Computing Group 2.0 standard for this. So these are just mainly authentication elements. So the main difference is that the authentication elements are going to be for more cost-sensitive applications. We do offer a line of ST-Safe products that are compliant to the DPM standards, the Trusted Computing Group standards. So this is really designed to be more authentication, not a full-blown TPM.
All right, let's move on to our next question, also an important one. How can we know more about ST-Safe A if we want to have a deep dive in use cases and implementation?
Well, there's quite a few online resources that are available. I know that there's a few YouTube videos that are out there as well that we've done from ST. But also, if you're interested in getting some more resources, there is a survey question after this about attending a possible ST-Safe A workshop. So if that's something you'd like to see in your area, please let us know. Okay.
And also, you can take a look at our GitHub page as well as our examples online, and it'll give you some code examples with our using a Nucleo L4 board that give you code and also show you the kind of flow of what you might use certain features on ST-Safe for.
Okay, let's move on to our next question. An important one, do I need an NDA to access the ST-Safe A120?
No, you do not. So the documentation is available online. So we have the data sheet online, and then also all of the code that's available for communicating to the ST-Safe. So the Xcube code is all source codes available. So it's just free for download. And also we do have the resources available on GitHub too. So.
And we have a question coming in here from Corey. Does ST-Safe A120 support any post-quantum cryptography algorithms?
So our A120 does not support PQC right now. Our next generation we are working on is coming out with PQC algorithms, and some of our TPM lines, our latest lines, will also support PQC. So I know that's a big topic coming up, but we're working on A130 that will support it, as well as some of our other products can dig into it.
All right, thank you, Kyle. We have our next question here. My project does not use the STM32 MCU. Can I use the ST-Safe A120 anyway? And what is the license for the software?
Yes, you can use a microcontroller other than an STM32 for this. So the licensing requirements are essentially as long as you're using an ST-Safe, A device, you can use the software that interfaces to that for free. And right now, the distribution for a lot of that software is done on GitHub, and it has a BSD3 license for that.
All right, thank you, Keith. We'll move on to our next question here. What type of interface shall I implement to use the ST-Safe A120 in my application?
So the ST-Safe A120 hardware interface is I2C. We provide a firmware interface, obviously, with our GitHub library for the STSC middleware. And in this, you'll find the I2C driver and the CRC driver, system time, and cryptographic primitives. So all these basically will be tied to the processor you're using, but we try to make it very easy to basically segment out what you need to change in the code versus what is inherently done by the library itself. So we're trying to make it very portable, and the only hardware interface that you'll need is the I2C connection there.
Okay, let's move on to another question. If I need EAL6+, shall I still benefit from the ST-Safe A120, that is EAL5+?
I could start that one out. So Well, typically with the EAL, so it's the common criteria, evaluation assurance level, there's two components to this. So there's kind of a documentation and, product development flow requirement, which is part of the EAL level. And then there's also what's called AVA_VAN. So it's the vulnerability analysis. That's of the physical hardware. So while the ST-Safe A120 is EAL level 5, so the documentation standards are to the EAL level 5, it's really that plus part that's kind of critical to that. And so we are AVA/VAN level 5 from the hardware anti-tamper standpoint. So that's one of the highest levels of physical robustness against external attacks that's out there. So if someone is trying to use differential power analysis, X-ray, microscopy, probe attacks, things of that nature, this device offers some of the highest level of hardware assurance as far as prevention mechanisms for those kinds of attacks. So really, I think you need to kind of more focus on the VAN level 5 as opposed to just the overall EAA level 5. So it's a little bit of a complicated question, but from my understanding is the EAL level 5 is much more on the documentation side of that. So
Ben has a question that just came in. Let me push it out here. And he says the data sheet shows AES as CBC support, but the X-Cube STSE01 doesn't have functions to perform this. Is there a way to perform AES as CBC using the A120?
Yeah, so there have been a few questions on that. There's actually an error in the data sheet that is pushing this out. We need to correct it. The AES CBC is not supported on the A120. So that is why the software library doesn't have it. This was in one spot in the data sheet that is not actually correct. In our user manual, it is not described, nor is it supported by our software.
All right, thank you, Carl. We'll go to our next one from Trevor. Do you have any general recommendations if we want to integrate the ST-Safe A120 with the SBSFU for firmware image authentication and decryption, especially with the SBSFU legacy?
So right now, we don't. SBSFU legacy is an older code base that we have. We don't have right now in our roadmap plans to update for the ST-Safe A120 specific STSE library. What I can say is that it will ST-Safe A120 is fully backwards compatible with the A110. So whatever you'll be totally safe getting an A120 in it working with the old package for the SBSFU. It just will not include the latest software library. It'll be the legacy ST-Safe software library, but there won't be any issues. It will still function because you're able to take out an A110, which is our older model, and plug it in with an A120, and it'll work the same. It's just the reverse doesn't work. We added more features and capabilities, but it's still backwards compatible with the A110.
All right, we'll have another important question here. Are the evaluation boards available? And if yes, where can I order one?
Yes, the evaluation boards are available, and those are available from the ST eStore and also through various distribution outlets. So.
And we have a direct link to the ST eStore at the bottom of your screen. And so you can order there directly. I will highlight it for you right here. It'll take you directly to the eStore and evaluation board. All right, let's see if we have any more questions here. Okay, let me take this one. How can we request a dedicated profile, and what is the minimum project volume for this?
So for a dedicated profile, so the minimum volume for a dedicated profile is 5,000 pieces a year. And typically what you would do is you work with us to kind of define the specific features that you want to see in your profile, and this would be the selection of the various cryptographic curves that you want to have supported in your part. as well as, potentially like the format of your certificates and things like that. And so that's something you work with our applications folks on to define your profile. And then once that's done, you would actually get a custom part number to order against. So Kyle, I don't know if you wanted to add anything to the profile customization there.
No, we'll work with you directly. If we're doing a custom profile, we will send out basically hand provisioned samples for validation, and then they'll be validated by you. Once you've done that, then we kick off the process with our production facility. Yeah, we can do various levels. It can be a specific profile where you tell us key size that you want us to inject into it to get your pre-provisioned identity, and we can do different segmentation of memory. We can do all that up to like, just if you don't care as much about, if you're okay with the standard profile, we can provide a standard profile with a custom CA for you. If you're going down that route where you want a specific CA that's only dedicated to your parts, we can do that as well. And that's a little bit simpler of a process because we don't have to fully customize the profile. But yeah, the MOQ, as I think Keith said, was a 5K for those customization options.
All right, I see we're almost at the top of the hour. Let's take one last question. Can we use the evaluation part number in a real project?
Yes, I'll take this one, Keith.
Sure.
Yes, so we have some available options to purchase called OCD. It's basically certificate distribution, where whenever you buy a reel, we provide you with certificates. So, if you don't want to do a custom CA and you just want to order a standard part, you can whitelist CA. Say you're doing a cloud project and you want this to be the identity that allows access into the cloud. You can whitelist certificates. There's a few different ways you can, authenticate. One of them is with the CA. So that's where I mentioned the custom CA. If you don't want to do a custom CA, you can just basically bulk upload certificates to the cloud, and they can, the cloud will whitelist these certificates. So anything that accesses it with that certificate will be allowed to enter and send data. So these can be read from the parts and uploaded, or we also provide a service of providing, if you buy a full reel, we can give you all those certificates and they can just be bulk uploaded. So, maybe you don't necessarily need a custom CA. Maybe your model doesn't use that. So it would be a lot faster and simpler to just buy the part. And then we also do provide provisioning capabilities for the part on your side, where you can go in and provision access controls for different commands and all that. So we're trying to make this part more user-friendly from the production standpoint, where you don't need us to do everything for you. So it is definitely possible to use the evaluation part number for a real project.
Yeah, and typically the way that this bulk upload occurs is that on the side of the reel there's a QR code that you can scan, which provides a URL, and that URL points to a zip file that contains all the certificates that are on the reel. So then you can pre-upload that to your cloud provider, maybe AWS, Azure, your own, what have you. So it makes it pretty simple. You just need a MyST account in order to do that. So.
All right, thank you both. And then this last question brings us to the end of today's webinar. If we were unable to answer your question today, please use our ST support option, and I'll highlight it. We have a direct link at the bottom of your screen. Once again, we will be sending all attendees today a post-event email with the link to the on-demand version of this webinar, as well as the additional resources. And the PDF of the presentation is already available in the resource widget, and that would be the second one to your left. So thank you again for attending today. We hope you were able to take away some useful information. And also thank you to those of you who took the time to answer our survey and poll questions. Enjoy the rest of your day, and we hope to see you again soon in one of our upcoming webinars. Goodbye.
Thank you.